Hello everyone, my name is Marisan Balagurgan. So today I am going to do a presentation about case study on failure analysis of machine element. So let's hop on to the introduction. Failure analysis is the process of investigating and identifying the cause of failure in machine components to improve reliability and prevent future issues. It plays a vital role in ensuring the safety, performance, and lifespan of mechanical systems by helping engineers understand how and why components fail under various conditions such as stress, fatigue, corrosion, or wear. This knowledge allows for better material selection, improved design, and effective maintenance strategies. In this case study, the chosen machine element is the absorber spring in a car suspension system due to its critical role and frequent exposure to harsh loading conditions.
Hello everyone, today I'm going to talk about suspension spring. So what do suspension springs do? They absorb pumps from the road and they help spread out the force so the ride feels smoother. They also hold the weight of the vehicle and they make sure the tires stay in contact with the road always. This helps to make the ride more comfortable and also keep the car more stable. Because of this, they help with better braking and turning. Why did I choose suspension spring? Because they are very important for safety and how the car performs. They go through a lot of stress every time the car hits a bump or hole. Also, they are used a lot when carrying heavy things. But they can get weak over time and may break or stop working if used in tough conditions too often. Now let's look at the objective of this study. Suspension springs failure can cause real problems on road, so it's very important to understand why they fail. This can help us make vehicles safer and more reliable. So in this study, we will look at how a suspension spring fails, and we will also suggest some ways to improve its design and make it last longer.
Normally இதாச்சுன்னா ஃபெயிலியர் ஆச்சுன்னா
ஃபெயிலியர் ஆகுதுன்னா அது கீழே ஒன்று தூள் பிடிச்சிக்குவோம், எல்லாம் உடஞ்சி போகுது அந்த மாதிரி.
உடையுதுன்னா எதுனால உடையாது?
அதுக்கு தூள் பிடிக்கலாம் உடையுது. ஓவர்லோட்டில் உடையுது. அப்புறம் இந்த சஸ்பென்ஷன் ப்ராப்ளம் கவனிக்காமல் இருந்தாலும் அந்த ஸ்ப்ரிங் பவுன்ஸ் பண்ணிக்கலாம். அந்த மாதிரி டைம்ல
இப்போ ஸ்ப்ரிங் இந்த சைஸ் இருக்குதானே? இப்போ இதெல்லாம் ஸ்டெல்லஸ் இருக்குது.
மண்ணுகளுக்கு நம்மளுக்கு டிஃப்ரெண்ட் இருக்கு. மண்ணுக்கு ஒரு சைஸுக்கு நான் ஒரு சைஸ் வரும். ஒரு காடிக்கு அதுக்கு தகுந்த மாதிரி அந்த ஸ்பெசிஃபிக் சைஸ் வரும்னா திக்னஸ்ஸு, அப்புறம் ஹைட்டு, இந்த மாதிரி அதுக்கும் ஸ்பெசிஃபிக் சைஸ் அந்த காடியோட வெயிட்டுக்கு ஏற்ற மாதிரி தான் அந்த சைஸ். ரெண்டு சைடு மாறும். ஏன்னா இது ஸ்டேபிளர் ஒரு சைடு காடியாக பாடி 1 டன் 4 இயர் இதெல்லாம் திக்னஸ் என்ன திக்காக இருந்துச்சுன்னா அதோட ஸ்டெபிலைட்டி இன்னும்
இதோட ஃபங்க்ஷன்
அது டஸ்ட் எதுவும் போகாமல் அதுக்கு மேலே மவுத்திங், கீழே அது மவுத்திங். அது ரெண்டு பிடிங்களா, அது நடுவில் அந்த வளையமாக இருக்கு, அதுதான் வேரிங்.
எந்த மெட்டீரியல் படிப்பாங்க?
மெட்டல் தான். மெட்டலில் ஈக்குவாலிட்டி மெட்டலிங் quality இருக்கு. A quality, B quality. நார்மலாக சஸ்பென்ஷனில் A quality தான் இரும்பு.
Hey, back to me. So now I will be explaining the parts that consist in a suspension system. So if you can see here, there are 5 parts consist in a suspension system. So first is bearing. Bearing contribute to smooth motion, load support, and overall driving comfort and safety. Secondly, mounting. Mounting is crucial for both comfort and the durability of the suspension system. So, thirdly, is dust cover, which is to protect suspension components from environmental damages. And next is absorber. Absorber ensures a smooth, safe, and stable driving experience. And finally, absorber spring, vital suspension part that ensures smooth driving by absorbing road shocks and maintaining vehicle stability.
Once I wouldn't say it, would I? Once you wouldn't. No. Bye.
This diagram shows the free body diagram of a vehicle suspension system. At the top, we have a sprung mass, which is a vehicle body, and below it's unsprung mass, which includes the wheel and axle. Between these two masses, there is a spring and damper that's form the suspension system. The spring supports the weight and absorbs shocks, while the damper controls vibration. The tire is modeled as another spring that connects the wheel to the road surface. The road disturbance is represented as a Y, and the vertical movement of the masses are shown as XS and XU. In some systems, an extra force can be added to represent active suspension control. This FPD helps us understand how forces act and move within the suspension system.
So now I will be explaining the possible failures of the spring. So there are several failures that can be found in a spring. So first is fatigue failure, caused by repeated compressive and tensile loading over time, and it leads to crack and eventual breakage. Secondly, corrosion. which is the exposure to due to exposure to moisture, road salt, and chemicals causes rusting. So it weakens the spring and leads to premature failure. So thirdly, the possible failure is fracture or cracking, which is due to poor material quality, excessive stress, or surface defects. Fourthly is sagging or loss of elasticity. Spring loses its ability to return to its original shape. It results in lower ride height and poor shock absorption. Fifthly, overloading. Carrying loads beyond design limits can permanently deform or break the spring. Next is improper installation or misalignment. It can cause uneven stress distribution leading to premature wear or failure. Next will be manufacturing defects. Includes surface imperfections, poor heat treatment, or incorrect material selection. And the final will be impact damage. It due to high impact forces, for example, hitting a deep pothole may cause immediate breakage. So, what are the design optimization ways to improve the spring lifespan? So, there are three major uh, ways to optimize a spring design. Firstly, is material selection. So, we have to use high strength alloy steels, for example, chromium silicon or chromium vanadium. Consider composite materials like fiber reinforced polymers for weight reduction and corrosion resistance. Secondly, optimize spring geometry. Design the coil diameter, pitch, and wire thickness to distribute stress evenly and to use progressive rate springs, for example, variable pitch, to handle both small and large impact effectively. And finally, will be the load and stress analysis. Use finite element analysis (FEA) to simulate real world loading and identify stress concentration and optimize the shape to minimize peak stress areas.
Good evening. My name is Patri Narayanan and my numeric is P0922100136. And today I'm going to explain about the FEA analysis of the product that we choose, which is the spring of the car absorber. So the applied force on the spring is 100 Newton downward axial compression, which have a maximum stress observed 149.45 MPa, and the yield strength of the material is 241.28 MPa. The stress type is 1 Mises stress, used for ductile materials. The highest stress regions are located at the inner curve of the coil turns, shown in red. Most of the spring body is within the safe stress range, indicated by blue to green color. Low stress level. The maximum 1 Mises stress 149.45 MPa is well below the yield strength 241.28 MPa, meaning no plastic deformation. Spring is structurally safe under this loading. So this is the analysis for the original design. Now this is the FE analysis for the optimized design of the spring. The parameter of the spring modified, which is the spring wire diameter, which increased from 10 mm to 20 mm. The applied force still remains the 100 Newton, which is not changed. And this time the objective is to reduce the stress and improve the durability than the previous spring design. The maximum 1 Mises stress is now much lower than the previous design, which is the previous design 149.45. The stress values remain the same, well below the yield strength, which is 241.28 MPa. The maximum stress observed in this optimized design is 19.98 MPa. The yield strength of the material is 241.28 MPa. The entire spring body shows low stress level, mostly blue-green shades. Maximum stress is only 8% of the yield strength, indicating excellent safety margin. Okay, So, for discussion, what are the findings that we can get from the optimized design of the spring? So, the first one is stress is uniformly distributed with no high concentration zones. The design is far from risk of yielding or plastic deformation. Increased wire diameter also leads to lower stress concentration, improved structural integrity, and higher stiffness and load capacity. Spring is now more durable and can handle higher loads or more cycles. And finally, the optimized spring is much safer and more efficient.
So, in conclusion, this case study highlights the critical role of the absorber spring in a car suspension system as a key component responsible for absorbing shocks, supporting vehicle weight, and ensuring ride comfort and cyclic stability. The spring is constantly exposed to harsh and cyclic loading conditions. Through failure analysis and design optimization, potential issues such as fatigue, corrosion, and overloading can be better understood and addressed. By applying proper material selection, surface treatment, and advanced design methods, the performance and durability of suspension springs can be significantly improved, contributing to overall vehicle safety and reliability. Thank you for watching the video.